During this video, I'm going to create drawings based off of all of the parts for the automata. And during this, I'm not going to go over the technical how do you use Onshape portion of that. That's actually in another video. What I'm going to go over is how do you select the views, how do you make sure that they are making sense. There's a specific way that we actually, there's certain standards that we use, conventions if you would, that allow one designer to communicate clearly with the person who's building it, the person who is ordering it, another designer who is making recommendations. And so how we align drawings and how we select our front view is actually very important. And then in addition to that, how we put those dimensions on are also important. So that's really what I want you to focus on here. So here I'm going to open up and create a new drawing. ANSI A inch, we'll go there. As it loads. And remember, the first view is just going to be the assembly, full-on assembly as an isometric. And this doesn't necessarily have too many conventions attached to it, but it is kind of a nice thing whenever you're making a project. It is nice to have your own the isometric there. If you want to, you can show the shaded view because isometrics are there just as a pictorial to show you what it looks like. Generally we don't show hidden lines and we don't put dimensions on there. In addition to that, I mean, obviously we are going to use our bill of materials and click there. Again, in another video I've already shown that portion of it. Next, I'm going to create a new sheet, and I do suggest this. By creating a new sheet within this window, you will be able to export all of these as one file, and it's very, very helpful to do that. So I'm going to insert a view. I'm going to make sure I'm getting a part, and I'm going to start on this part right here, part 3, because it's fairly complex and it kind of will be a good example for this. Okay, so I've got part 3. From this view, it looks like it's fairly small, so I'm actually going to make this bigger. This view scale doesn't have to be something specific, but it is going to be, I might even pick 1.5 to 1. There we go. So I'm going to use this as my front view, not because the computer says it is the front, but rather because if I were to use this as my front view, I can't really tell what's going on there. I don't understand the shape. I don't actually know without hidden lines if there are holes in it, and even if there are holes in it, if those are square, are they round, are they some other shape, we don't know from this view. So I'm not going to pick this view. I'm also not going to pick this view because, again, it looks like a rectangle. It might have some rounded corners. It might have ones that are at angles. Chamfers is what we call them. I can't really tell. I don't know what this looks like. But if I look at this view right here, I can see that it is essentially a rounded rectangle. It has a couple holes in it, and those holes are circular. That tells me a whole lot about this part. The next requirement or thing that we try to do is have the longest dimension on this view. And so right here I can see that the longest dimension is there. It is also horizontal, which is kind of a preference as well, because our paper is horizontal, and it makes more sense to do it that way. So this is going to be my front view. It looks like it describes the part the best. It has the longest dimension. It looks like it could sit there. It looks like it's in a pretty natural position. And so this is going to be my front view. The other thing is, and you can't really tell because this is symmetrical, I also want to be thinking about what are those other views going to be looking like, and can I avoid hidden lines as much as possible. We can't dimension to hidden lines. We want to avoid them if at all possible. And so this one, it doesn't matter if it's the right or the left if we rotate it. However, it still is going to show the same amount of hidden lines, not only in the front view, which is hopefully few, but also in the right hand side view, which is what I'm going to put there. The front view, not only do you select that, it also goes into this kind of quadrant, this bottom left area, and we're going to leave a little bit of space around it because we want to make sure we have room for dimensions, that it has some room to breathe as well. We want this to be clear and easy to understand, so we're going to make this not too close to anything else. Okay? So I click there, I've got my front view, and automatically Onshape and most CAD programs, to be honest, are going to give you what's called a projected view. A projected view is a view that aligns with it as the orthographic projection is supposed to. Okay? So if we are diagonal, this is the view that would be our isometric in that corner. We're not going to do that. We're actually going to put the right hand side view right here, and you can see that it lines up. I'm going to click, and I'm still in that projected view tool, so I'm actually going to click and give us that top view, though we may get rid of that one. We will see. And then if you want, you can have an isometric. If you don't, that's totally fine as well. Beginning CAD classes tend to have the front, the right, and the top. Generally, that's how we do it. Now, if we look at this, I can see that this shape is essentially here. It's got a couple rounded rectangle, a couple circles, and then it's a certain thickness. And that's about it. There's nothing that this particular view shows me that these two views don't already show me before. So that tends to be where we take one of these views and we get rid of it. Then we can also move this isometric kind of towards the middle. This allows us to have a balanced page. It's not too full of things and it's not too empty of things as well. From there, I'm going to put dimensions, and the first thing I like to do is I like to put the overall dimensions, and I'll often move them up here. I'm going to put mine up a little bit, but I may move it down a little bit. The dimensions, the numbers themselves, should be centered between those arrows, so along that line, and we want to make sure that our dimensions, whenever possible, and it usually is, are off of the part. So we don't want to put it here, it's just a little more confusing. We want it to be off of the part. In addition, I'm going to do the overall height. We work in 3 dimensions. So we've got the width, the height, and then the last thing is the depth. From there, we can actually dimension the location of these holes. So we've got one that's a 1/2 inch, and they both line up. So I'm just going to put the one, and then the width here, and I can actually put one from that edge over here as well. Now it looks like I've got a little more space than I need here, but I have pretty good spacing along here, so it's actually not too bad. So So that's going to be good dimensions right there. Two last things. We've got a rounded fillet right here, and I think this is small enough that we don't need center marks. And then we also have a couple holes. So I'm going to check and see, does my hole call out? And sometimes it's in the drop down menu, but it's right here on my screen right now. Does it allow me to dimension? And it doesn't, so that's okay. We'll just put in a dimension and I'll show you how to change that as well. So we've got a hole, and generally what we want to do is also define the depth, how far down it goes. This one goes all the way through, so that's THRU. Other times we'll put in symbols as well, but if you have a hole that is more unusual than that, then you might, you would probably have be using the hole function anyway. Another thing that is very helpful, I'm going to put this right here, is that there are actually two of these holes that are exactly the same, and so we can actually put what's called a quantity note. So I'm going to put a 2, a capital X, and then I'm going to put a space just because I like a little bit of space to make it easier to read. And so now I know by reading this that I have two holes that have a diameter of 0.375 and they go all the way through. There we go. That is fully dimensioned, but we're not quite there yet. And I'm going to show you one last part of the drawing. So we've finished up all of our dimensions, and I'm going to show the hidden lines. You can see them lined up. We also want to use center lines, and so here I'm going to click on the top and the bottom of that, and adds a center line, long, short, long. I'm going to also add one, and since they actually share a center, I can actually create a center line that crosses through both of them. So long, short, long, vertically this way, and then I can also do the same thing over here so that that center line, it's very clear that it's cylindrical from this view. So there you go. That is a fully dimensioned, I know exactly where everything is. I've got center lines on all the circles. I have defined the size and location of everything. My front view is the most descriptive. It has the longest dimension, fewest hidden lines, and seems like it's in a natural position. That is in that bottom left quadrant. My right hand side view lines up with it, and so just to show you, once I move this, this should move. That projected view will do that for me. The isometric is nice, but again, not required. And so if you don't have that, that's fine. But I definitely am looking for your views, your drawings, to have dimensions and have them line up in this way. And then to have that front view be in this kind of fourth of the page with all of your other views aligned to it, so your right hand side and top if needed.